Every reasonable problems have solutions. Some will take time, but most have tricks to play. Welcome to Mr. Wang Knows the Trick for AMC8. Lecture 2. What year is this? What year is this? I think, of course, those who made the AMC8 test are pretty good at math, and they wish to play with a twist. The number of this year is something that is not easy to find a pattern for. If this year is an even number, next year will be odd. 2017 is a prime, but 2018 is not. So in this lecture, Mr. Wang does not really have a trick to share. It is more like a reminder. Problem number 1. It's AMC 8, 2011, problem number 22. What is the 10th digit of 7 to the power of 2011? 5 answers, A, B, C, D, and E. Well, how do we solve this problem? Look, they like to play with the number of the year. This is 2011, and they have 2011 in the problem. Well, the one way to solve this problem is to calculate out exactly what is 7 to the power of 2011, but it's not practical. You can't do this, especially on a time-limited competition. Is there any other way? Solution. Let's look at it. 7 to the power of 0 is 1. 7 to the power of 1 is 7. 7 square is 49. And 7 cube is 343. And 7 to the power of 4 is 2401. And look, this already got a repeat. 7 to the power of 0 is 1. You can consider as 0, 1. And 7 to the power of 5 is 16800, which is you can it's 16800 plus 7. You can see the last 2 digits is the same as this. You can see you can put a 0 over here. So 5 equals to 1. 4 equals to 0. As you can see, the last 2 digits circles after every 4 powers. 7 to the power of 1 mod 10 mod 100, that means the last 2 digits is the same as the last 2 digits as the 7 to the power of 5. If you continue, you will figure out it will be also the same to the 7 to the power of 2019. If we continue, you will see if we continue the other way, 7 to the power of 2011, which is the question, the number we want to figure out, has the last 2 digits the same as 7 to the power of 7 and also 7 to the power of 3. Here we go. The last 2 digits is 43. Therefore, the answer is D. The 10th digit is 4. Problem 2. This is AMC8, 2012, 2012. Problem number 12. What is the unit digit of 13 to the power of 2012? 5 answers again, as usual. Well, we learned some trick. We know now we don't want to calculate exactly what is 13 to the power of 2012. We can get the hint from what we get last time, and let's see if we can use the same trick again. Here we go. Here's the solution. Let's see. The problem wants us to find the unit digits of 13 to the power of 2012. Therefore, we can eliminate the 10th digit of 13, because really this this 1 at the 10th digit of the 13 does not contribute to anything to the result. It has, the 10th digit will not affect the final result. As a matter of fact, whether this is 1 or 2 or 3, it doesn't really matter. Actually, it's the same as 0, so we only have to consider the 3. Our new expression is this. Now we need to look for the pattern in the unit digit. As we know, we can ignore the 10th digit, and by looking at it, we can see 3 to the power of 0 is 1. Well, to be clear, the unit digit of 3 to the power of 0 is 1. The unit digit for the 3 to the power of 1 is 3, and so forth. The unit digit is 9 for 3 to the power of 3, and 7 for the 3 power 3, 1 again to the power of 4, 5, 3 again to the power of 5. We can see again, we see a circle, right? It's a pure coincidence that it is circle of 4, but so be it. This symbol, 3 dots, 2 on the top, 1 on the bottom, means since. Since 3 to the power of 2012 equals to 503 times 4 plus 1, plus 0. Therefore, the unit digit of this equal to the unit digit of 3 to the power of 0, which is 1. The answer is A, 1. Problem number 3. This is the AMC 2016 problem 9. What is the sum of distinct prime integer divisor of 2016? Again, they're playing with the year, the number of the year. And this is just to show you another possibility how they're going to play. The solution is actually simple for this problem. All we need to do is to find all the prime factor of 2016. And factorization tells us that 2016 equals to 2 to the power of 5 times 3 to the power of 2 and times 7. So the 3 distinct prime divisor is 2, 3, and 7. Therefore, the sum of that is 12. The answer is B. Last question. Problem 4, that's the AMC8 2018, problem number 7. The 5-digit number 2018U is divisible by 9. What is the remainder when this number is divided by 8? So there is a 5-digit number. We play with 2018 in front, but there's one more follow it. The unit digit is U, and this number is divisible by 9. So he's asking what is the whole number, the 5-digit number, what's the remainder if it's divided by 8? And that is also a simple problem. Solution is, as we know, if a number, if and only if the sum of each digit is divisible by 9, then this number is divisible by 9. So since 2018U, this 5-digit number is divisible by 9, therefore 2 plus 1 plus 8 plus U is also divisible by 9. The number 0 obviously doesn't contribute to this. That is 11 plus U is divisible by 9. And since U is the last digit of a 5-digit number, so U is bigger or equal to 0 and smaller or equal to 9. Therefore, U equals to 3, and the 5-digit number 2018U is actually 20187. 1 divided by 8, the remainder is 3. So the answer is B. So here's the summary of this lesson, of this lecture. AMC likes to play with the number of the current year. Although the number of the current year all have different mathematical characters, and we can still do some preparation for it. Obviously, this year is 2020, and here are something we can find. First of all, if we prime factor it, 2020 equals to 2 times 5 times 101. Another thing is 2020 actually has a very unique feature. It is the sum of 4 consecutive prime, the square of 4 consecutive primes. As you can see, 17, 19, 23, and 29 are 4 consecutive prime, and the sum of the square of the 4 is 2020. If they happen to use this in the AMC8 test, it must be a very later problem, and because it's difficult. As for others, well, it's up to you to figure it out. Thank you for listening to this lecture. See you next time.